Many teachers have difficulty providing their learners with opportunities to develop the correct understanding of the more abstract but basic chemical terms, such as atoms and molecules and elements and compounds. In today's lesson, we try to remedy that situation. The outcomes for the lesson are that learners are able to distinguish between atoms and molecules and elements and compounds, and can use a two-dimensional model to demonstrate the differences between these concepts. The teacher first briefly introduces the learners to the periodic table, explaining that all the substances on it are represented by symbols. The teacher then distributes a collection of colored discs to each group in the class.
Okay, those cycles, they represent atoms. Just look at the sizes, they are not the same. Those colors and those sizes give them something. They give them a concrete thing in their minds rather than to use a chalkboard. Sometimes they forget what you taught them.
The teacher then lists 8 elements on the board and says that the learners should decide which disc should represent which element, arranging the discs from smallest to largest, depending on the size of the atom.
By mere looking, which one are we going to put as hydrogen?
The green one.
The green one is the smallest one.
The teacher then refers the learners back to the periodic table to find the element with the second smallest atom.
You can see it's H, it's He.
The learners identify the second smallest disk to represent helium. They then move through all the 8 elements on the list, choosing the appropriate disk by size for each one.
The navy one.
This ordering process helps them become more aware of the relative sizes of the atoms of the elements on the list. The teacher then asks the learners to group the discs according to their different colors, while keeping the discs from overlapping.
Some of the sizes, they are the same, and some of the colors are the same. What I want to know from you guys is how many hydrogen atoms do you have on the table? 5. What I want to know, what does that mean? What does that imply to you?
So all the hydrogen atoms are the same size.
And this implies that they are identical.
But what exactly is an atom? The teacher explains that it is the smallest particle of a substance that can take part in a chemical reaction. The teacher then moves on to discuss molecules with the learners.
If you can look here, I brought the two together. What are these? Which atoms are this? Hydrogen. Okay, hydrogen atoms. Then which one is nitrogen? The orange one. The orange one is our nitrogen. Then I put the nitrogen together.
The teacher combines various discs of the same color, but when he comes to combining the helium atoms, he stops.
Okay. Which one must I put together?
The helium.
Helium. I can't put helium together. Who can tell me the reason why I can't do that?
I think, sir, maybe it's because they don't attract together.
They are what you call noble gases. Anything found in the noble gases, you can't put them together.
The teacher explains that the noble gases are examples of substances that are inert. Their atoms generally don't take part in bonding or chemical reactions.
Who can tell me? But by putting them together, what are we forming? What are we forming?
I think we are forming the molecules.
We are forming molecules. We are forming molecules. Then, my question is, because you said you are forming a molecule, who can tell me what is a molecule?
I think molecules are those substances that are work together.
The learner has misused one of the key terms, substance, so it is important for the teacher to correct her misconception at once.
Atoms.
They are atoms.
The teacher gives the learner an opportunity to correct her answer.
Molecules are those atoms that are working together.
Very good. It's when the two or more atoms are joined together. Then my question is, how many substances do you have there?
I think 6 substances.
How many molecules are represented here?
6 molecules.
By asking learners to count the molecules, atoms and substances, The teacher is compelling them to distinguish between the different concepts and reinforcing their understanding of them as separate from each other. By their responses, he can check whether they are understanding the concepts correctly. The teacher should emphasize that some molecules may consist of more than 2 atoms. In the case of sodium, for instance, a number of atoms come together to form a molecule. At the conclusion of this activity, the teacher reminds the learners of the activity's main messages. Particles of matter can be described as atoms and/or molecules. Particles of a particular substance are identical to each other. The teacher starts the new activity by referring back to the periodic table.
This is what we call this the periodic table of the elements. Okay, when we look at the element number 1, who can tell me which one is our element number 1?
The first element is hydrogen.
The second one is helium, lithium, beryllium, and so forth.
He then instructs the learners to construct different kinds of molecules with their disks composed of atoms of more than one element.
H stands for hydrogen. Then we have C, L. And Cl stands for? Chlorine. You have the circles on your table. Can you please do for me the structure for HCl?
Once the learners have put together their molecules, the teacher then instructs them to make other molecules. Sodium chloride, carbon dioxide, and water. The learners construct each molecule from the disks on their table. The teacher moves from group to group, assessing their progress and giving advice if the learners are going astray. Once the groups are ready, a learner comes up to the board to show how his group constructed the specific molecule.
H2O. Is that correct? No.
In time, the learner comes up with the right answer.
Let's look at sodium chloride. Sodium chloride. Are the size of the atoms the same or not the same at all?
They are not the same.
They are not the same. By looking at these things, I say these are what you call compounds. Who can tell me? Who can define for me this word compound?
I think compounds are different atoms that are combined together.
Very good. Like for instance, if you look here, it's a hydrogen and chlorine. Who can tell me what's the difference between elements and compounds?
The elements is two atoms together, and the compounds are different atoms combined together.
When it comes to compounds, the learner is correct, but he has failed to understand that elements consist of only one kind of atom and may be represented in atomic or molecular form.
They can be represented in an atomic form. By atomic form, just like when you say hydrogen, this is what you call atomic form. You see, and they can be represented in what you call molecular form. We talk in terms of what you call H2 as a molecule.
Now the teacher can refer learners to the board and ask how many molecules are represented on the board, how many atoms in each molecule, how many different elements, how many elements in atomic form, how many elements in molecular form, and how many compounds. The questions will help reinforce the learners' new knowledge of the different concepts and will help the teacher to assess their progress. To end the second activity, the teacher recaps with the learners that elements may consist of atoms and/or molecules. Matter can be described as consisting of elements and/or compounds, and compounds always consist of molecules. The teacher has used the magic spectacles model of atoms and molecules in this lesson, and there are some risks associated with it.
Learners get the impression that an atom or molecule is a flat structure. They get a concept of the fact that a molecule or an atom has a particular position in relation to another atom in the formation of a compound.
But if the teacher emphasizes that the disks are merely being used to represent atoms and atoms themselves are three-dimensional and colorless, then learners should gain great benefit from this approach as opposed to a traditional chalkboard approach.
It was not easy when I was using the chalkboard method because I stand there like a preacher. See, they are not involved in my lessons, but today they were involved, they were doing all the activities.
Hello viewers at home. We have just watched a video on a chemistry lesson and would like to comment and actually discuss the lesson with the people at the studio. Next to me there is Liz from WITS, Mike from WITS, and Kanye from the Science Education Project.
Hi.
We have seen the teacher teaching a chemistry lesson, and one of the things that he did was to bring in some plastic discs with different colors. How do you find this way of teaching chemistry?
I think it's wonderful because chemistry is very hard to visualize. Can be an extremely abstract discipline, and many learners don't understand the meaning of a formula or a reaction equation. So I think this was an excellent way of introducing chemistry.
Why do you think the sizes, the colors, and the patterns were important in the disc that he had chosen to teach atoms, elements, and compounds?
I think the size was bringing out the fact that the atoms are different sizes, and also helping the learner to articulate one particular color with a particular atom, which is distinct from the other atom. So when you pick up your green and it's big, you already know, oh, this is chlorine, or whatever they decided on it.
And do you think, Mike, is this a good way of introducing a lesson like atoms, elements, and compounds?
Yes, I think at that level, I think it is a good idea. Of course, one must be a little bit careful with using models, that one doesn't take it too far, because the chlorine atom, I don't think, is really green. If we could see an individual chlorine atom, but within that sort of limitation, I think that the models are a good idea. I think the comment that I would like to make about that lesson was the comment made by the teacher right at the end, and he said, "I don't want to be a preacher," and that was very nice. It means that he sees the limitations of trying to teach chemistry on a chalkboard, and so clearly the use of these discs is exciting for the learners, and it involves them. You could see that the learners were certainly enjoying the lesson, and if nothing else, we must hope that our learners enjoy science.
Just to add on what you're saying, what is even interesting is that he was actually using the chalkboard, but the way in which the chalkboard was used was centered around the questions that he had to ask learners about the discs.
Yes,
so the disc played a very important role in developing in the development of the questions that the teacher had to ask. So I think that was a good thing that he did.
Yes. And it was almost as if the learners had a board in front of them, because they had their discs on the table, and so they could move those around as well.
And what is even interesting is that those discs are associated with games, so we can play games also in chemistry lessons, which is exciting for the learners. The other thing that the teacher did in starting off his session was actually to use a periodic table chart. Is it easy to get a periodic table charts in our schools, especially the township schools?
There are charts that have been made available by companies commercially with advertising around the science. So I think that it should be possible for every teacher to have a periodic table chart in their classroom.
And what is the value of using the periodic table chart in the classroom, in the lesson like the one that we have just seen on the video?
Well, I think it gives the teacher a very useful ready reference, which of course is a reference for the learners as well. So obviously when he talks of any particular element, he can refer immediately to that chart, and the learners sort of get to know the elements.
Another one would be to say, sorry Liz, the charts reminds the learners of the differences in size. And then number two, it also reminds them on how they are reactive So this element can combine with that one. This one will not combine without explaining it, because it's there and it speaks to them.
Yes. And the periodic table is the main organizing system in chemistry. As we understand chemistry, it would become rote learning unless one had some kind of a system in which to explain why things react together.
There is a big debate about the elements in the periodic table. I remember when I was doing my chemistry, I was forced to memorize at least 20 elements of the periodic table. Do you think it's a good idea to ask the learners to memorize the elements, at least some elements in the periodic table?
There are some things. There's no way one could work out the symbols. So one needs to learn that C is for carbon and Cl is for chlorine.
As long as they don't memorize them like you memorize the alphabet, because the alphabet is just 1 up to 26 without relating it to a position.
Or categorizing them, that is on the left or on the right or at the center.
So they memorize it and against the structure, the background structure.
In a meaningful way.
In a meaningful way, yes.
So that if they looked at the different groups and related that to, as you said, to reactivity or size and so on, that would be helpful.
I think that the association between the symbol and the element is a process which they should acquire by sort of osmosis, acquire it gradually and within context and simply through practice. So it is just basically every time we talk about oxygen or carbon or copper, the teacher will point to the symbol in the periodic table, and then gradually they will get to know the one-to-one relationship. And then, of course, obviously there are those elements which have Latin names, which will require some explanation from the teacher.
And Mike, you've brought in a very important point of symbols in the periodic table, because what I have seen, the mistake that learners usually do in writing symbols, let's take for instance HCl. They'll put a big H and a big C and a big L. And that is very common among our learners. And how can one overcome such problem?
Yes, perhaps it just needs the teacher to point out that every element has a symbol. The first letter of the symbol is written as a capital letter, and the other letter is written as
a small letter. And learners must know that is a rule, and we have to stick to it.
What I really liked about this lesson was the pictorial representation of molecules. Because that's such a difficult concept for learners to grasp. And I think that was very good.
Are there any models that you think a teacher can use to show the whole idea of elements and compounds?
You mean out there in the market?
Out there in the market, yes.
Yeah, there are. Some use different colored spheres. Other people sell like your plasticine, different colored plasticine. They use quite a number, but I think this one was cheap for one and easy to use.
I also get my students to make their own models out of waste materials. So they use old broken tennis balls, and they use the tops of roll-on deodorants, and they glue them together, or they make them out of paper mache. So I think there are many different ways that one could represent molecules in 3 dimensions. But this is excellent in terms of the 2
3-dimension. You're coming with a key point, because this one, there was a discussion that the limitation is that it represents them as flat. So your idea is giving it as 3 dimensions.
Well, I think the 2 would complement one another. And learners could make drawings as well, using different colored pencils and actually draw the molecules. They don't actually need the cut-out circle.
And the lesson was in a way leading to chemical equations. What will be the best way of introducing chemical equations after this lesson, or towards the end of this lesson?
He would have to revisit the groups, group 1, group 2, group 3, and then, because it seemed to me that they were combining them from memory, knowing that H2O has 2 hydrogens, carbon dioxide has 2 oxygens. So they know why, they can tell why it will combine with 1 element, for example, and not 2. So they will revisit the groups. the noble gas structure. Then from there, it will lend itself into chemical equations.
And if a learner had a simple chemical equation, the symbols written down, they could put the two-dimensional model of the molecule under each of the symbols, and they could learn how to balance the chemical equation by adding more molecules in order to balance it.
So they could take, for instance, the balance equation for hydrogen and oxygen making up water. They could actually start off with some hydrogen molecules and oxygen molecules, and they could see how they would break up and proportion recombine, and they would see that out of one hydrogen molecule and one oxygen molecule, you're not going to get one water molecule.
Yes.
And so, in a sense, by a trial and error process, they will come up with the correct balance.
If you had to change this lesson, what are the things that you change? If you have to teach the similar lesson?
I think one of the things that I would like to see is learners being able to distinguish between mixtures and compounds, because that's quite a common point of confusion. Because we have two different kinds of atoms in a molecule of a compound, learners think that compounds are mixtures. And it would be quite a good idea to give examples of, for instance, hydrogen and oxygen molecules mixed together.
Yes.
And to show them the difference between that and water molecules. So it brings out the point that a compound is a pure substance.
Another point for me would be for them to identify the natural compounds. Like he was talking of oxygen and carbon and hydrogen as if they exist as atoms, whereas we know that they are diatomic molecules. So it will be nice for them to see that this doesn't actually exist in nature like this.
As a free atom.
And why? Bringing back this complete octet.
And I think that is all what we have for today. Thanks, Liz. Thanks, Mike. And thanks, Kanye. Thanks to the viewers at home. We'll see you next time. Bye-bye.